This illustration 18-72 is dealing with the calculation. Now, notice we're going to size the conductors in the boxed-in information, left-hand side of the boxed-in information illustrated. And notice in step 1, we're applying 430.6A1, which refers us to table 430.250 to select the full load current of the motor, not the nameplate, but the full load current from the table. So the 25 horsepower has a 68 amp full load current rating based upon the voltage and the phases of the motor. Now step 2, we go to 455.6A2, and we pick up 250% of 68 amp. We come up with 170 amp as instructed. And in step 3, we apply what we call in the industry the golden rule, 310.14 informational note 2 or item 2, a lot of folks call it, and table 310.16 after we have calculated the size of the conductors in step 2, and we come up with 170 amps requiring a 2-aught conductor from table 310.16, column 75 degree column, number 2-aught. So the conductor sizes is THW copper conductors, 2-aught in sizing. Now the overcurrent device for the input side, as well as the conductors for the input side, is sized at 250%. So the conductors tag along at 250% also. But now we use 455.7b, and we take 250% of 68, as we did in step 1 for sizing the conductors, and we come up with 170. The application of 455.7b as in boy, and 240.4G, as well as table 240.4G, and 240.6A, as well as table 240.6A, 170 amp, we round up to 175, and the size of the overcurrent protection device is 175 amps in the coordinates now, by being allowed to do this, by table 240.4G, because it's a motor load that has an inrush current when starting and running and accelerating the load, and sizing the protective device in 240.6A, as well as table 240.6A, then this illustration 18-72 sizes the conductors and the overcurrent device for a specific load using a 250% rating.